we can have nice things.
Okay, Israel,
Here.
Felix,
Here.
Eli,
Here.
Edith, Dahlia, Stephanie, Diego,
Right here.
Jamie Lynn,
Here.
Sandy,
Here.
Brandon,
Here.
Brian,
He's here.
Juan,
Here.
Martin,
Here.
Ann,
Here.
Kennedy,
Here.
Giselle,
Here.
Leo,
Here.
Gustavo, Lirio,
Here.
Tyler, Melanie, Lazaro, Jonathan,
Here.
Messiah,
Here.
Joanna, Kevin,
Here.
Ehong, Christina,
Here.
Johnny,
Here.
Luis,
Here.
D'Anthea, Brian.
Hi.
Okay, a few more seconds and we're gonna get started. We're gonna check them.
Chico.
Johnny, when do you want to take your limited units yesterday?
Okay, you probably won't finish during lunch, because it's like a 15-minute test, and lunch is like 20-something minutes, so it might take like 2 or 3 lunches. So like you can like, or you can like start it in lunch tomorrow, and then like finish it up full Thursday or Friday.
Okay, y'all, we're going to go ahead and go over this. This first part of our do first is basically kind of like the first half of our lesson, because today's a short day on a Wednesday. Okay, so kind of stick with me as we go through. Before we do that, we are starting our new unit. So, you might have noticed that we've been kind of like weird on the problem sets. Your problem set was due yesterday, which typically would mean you would get a new one today, but you'll notice there was not a blue folder full of problem sets. So you get kind of a break until Monday, because I want to get back to the like Monday to Monday schedule. So you'll get a new one starting next week for this new unit. The one task that I do have for you tonight is not like really that math related. In this unit, we're going to have a bunch of like relationships, what we call trig identities, things that you'll know like, oh, sine squared plus cosine squared is equal to something else that it simplifies to. And so we're going to be working on memorizing those. So similar to how in Unit 4, y'all always had your unit circle out in class, in this unit you're always going to have out what I'm calling like your trig identity flashcards, okay? So instead of you guys taking the time to like write out all of the flashcards, I saved you some time and I went ahead and made them myself on the computer and printed them on some bright paper so that you hopefully don't lose them. The only thing I didn't do, because it would have taken me years, is actually cut them out. I know, I didn't make them until late yesterday. But, so what I'm asking for y'all, your only task, because you don't have a problem set, is to work on starting to cut these out. If you would rather rewrite them because you want them on note cards because it's like thicker, or you want to just like practice writing them, you're welcome to do that. But you need to have some trig identity flashcards cut out or made ready to go. Tomorrow I'm going to check them, but then I'm going to check again on Friday for anyone that doesn't have them. Everyone, 100% of us definitely need to have them done by Friday, okay? There are 2 pages, so this is why I didn't put it in a folder, because I didn't want you to grab only one of them. There's 2 pages, and you'll notice like the second one, for example, doesn't have 2 at the bottom. Those are just blank because I didn't have any more to give you. So there's 2 pages, so I'm going to pass this pile around, and if you can grab 2 and then pass it along, that would be great. This is your only task to do, so please just carve out some time to do that for me so that you'll have them ready to do. Okay, so I'm going to move on back to the do first, and you guys pass those around. First one, should have gotten x squared minus 4. Second one, 9 minus d squared. Third one, a squared minus b squared. Now, what did y'all notice happened in all of these examples, if you did your box method, what was special about like these three cases compared to most other like box method expanding that we usually see? Kennedy?
One of the values cancels out because it has
Yeah, so we've got the two middle terms like canceling, because for all of these, one was like +2 and one was -2. Or the other one, it was -d and +d or whatever it was. So when we have that situation where we have the same, what we call like binomial right here, but with different signs, plus or minus on the inside, we call that this relationship a difference of squares, which means when they cancel out, we're just left with the first term squared, x squared, and the last term squared, 2 squared is 4, and subtraction because of that positive and that negative, okay? So, my goal, as we get prepared for this unit, we're going to recap today some algebra rules like this one, which is called a difference of squares, so that instead of every time drawing your box, I saw a lot of you that like box, box, box. I want you to start to see that difference of squares. Oh, I can do that really quickly. I know that this is going to be x squared minus 4 just by looking without actually taking the time to write that down. Okay? Let's go over to the other side and see if we can use that now to go backwards really quickly, because I didn't see everyone finish these. So if I want to go the opposite direction, if I was given x squared plus 4 or minus 4, and I wanted you to write the x plus 2x minus 2, who can tell me what we would get if we factor x squared minus 9 and go backwards? Melanie?
Would it be x plus 3?
Yep. And then,
x minus 3?
perfect. X plus 3, x minus 3. Okay, so instead of squaring the first and the last, now we're saying, okay, take the square root. Square root of x squared is x, square root of 9 is 3. And that's why anyone try to set up their box with this one, and you like had 0x, you didn't have that middle term, right? And so we can do the box with 0, but we're going to just notice that that's always going to be x squared minus 9 is going to be x plus 3, x minus 3 in our head, okay? So next one, 16 minus a squared. Think of the square root of 16 and the square root of a squared. Giselle, what'd you get?
X plus 4, x minus 4.
Close.
Wait.
With yours, you'd have a squared minus 16. We want 16 minus a squared.
Sorry. So, is it negative a
You can do that.
plus 4 and then a minus 4?
You can play with your negatives positives that way. If you want to just, whatever one's first still stays first, you can also say 4 plus a, 4 minus a, like that, right? So instead of, the a does not now magically go in front unless you make it negative for one of them. Just 4 plus a, 4 minus a, okay? And last one, if I take the square root of 4c squared, just a little bit more complicated, square root of 4 is, just shout it out, 2. Square root of c squared, c. So that just means I'm going to get 2c for both of those, okay? Square root of 25 is 5, and d squared would be d, so that means this term is going to be 5d, and same thing as before, it's the difference of squares, so we're going to have one that's positive and one that's negative, okay? So, key takeaway, I'm not going to I had a sentence here, but I'm not going to put it up because I don't want y'all just take all this time writing it down. Let's kind of think, I'm going to kind of summarize. When we are expanding, when we're going this way, we're squaring the first term and the last term, right? Right? So say square, if you don't want to take the time to actually do your box, if you notice it's the difference of squares, you're going to square the first and last term. And what do you notice about the operation for all of these? Add, subtract, what did they all end up as? Subtraction, because of the positive and the negative, it's always going to be subtraction. So and subtract those two things. So if I tell you this really quickly, you're like, okay, square the first one, that's the difference of squares. Square the first one, that's x squared. 7 squared is 49, so I'm going to have x squared minus 49. Boom, I'm done, because I know the 7x and the negative 7x will cancel out. Okay? Alright, for when I'm going the other way, instead of squaring, this time I was going backwards, so I square root, right? I square root the first and the last. And then I've got one of them that's plus, and one of them that's the minus term, right? They're just opposite signs, however you want to say that. You can say that your binomials have opposite signs, or one of them is going to be plus and one of them is going to be minus, right? Once we take the square root. Just quick summary, however that makes sense in your head. Okay? Alright, so one thing that you're going to see throughout this unit, but actually not with x's and a's and 2's and 3's, you're going to see with like sines and cosines here coming towards the end of the week, is this type of stuff where we're like factoring or we're expanding and going back and forth. And so the same rules are going to apply, so I'm going to be referring to a lot like, hey look y'all, this is actually like a difference of squares, so we can do this. Just square the first and last, or square root the first and last, okay? Another thing we're going to see a lot is sine and cosine and all these things in fraction form with like the tops and the bottoms. And so I want to recap now some things, some rules with fractions, with adding and subtracting fractions, and then also with like canceling things out. A lot of times y'all are like, ooh, I think I can cancel that, but I'm not quite sure. So we're going to kind of recap a few of those things right now. So flip the page. Let's talk about some fractions here, and then look at some proofs. All right. Let's talk about canceling numbers. Up at the top, it says, canceling out numbers in the numerator and denominator. You circle can, let's talk about first when we can, so circle you can cancel out numbers or variables in the numerator or and denominator whenever there is, box this, multiplication. That's the key idea. In the numerator and the denominator. We can cancel when there's multiplication. So a nice basic example, y'all are going to be like, yeah, duh, I know this, but just stick with me. When we have 2 times 7 over 2 times 5, what can we cancel? 2's. Y'all are like, oh, I see a 2 on the top and the bottom, I'm going to cancel it, and that's 7/5. The reason we can is only because there's multiplication. Those are common factors. We couldn't do that in other cases. Okay? So let's talk about now the flip side when we cannot. Here we go, second bullet point. You cannot cancel out numbers and variables if there is addition or subtraction. Unfortunately, it's tempting, but don't do it because it's not equivalent. So if you have 2 plus 8 over 2, you're like, ooh, 2 on top, 2 on bottom. You're like, ooh, I'm going to cancel it. But then you get 8. And that is incorrect because let's check. 2 plus 8 is 10 divided by 2. Uh-oh, that doesn't give me 8. That should have actually, the answer should have been 5. So that is not equivalent when we cancel the 2's. Alright? Over here, 14 divided by 10 simplifies to 7/5. So like we would be good. Those are the same when we cancel the 2's. Alright? So multiplication, yay. Adding and subtracting, no. Okay? This one is multiplication, so the y's and the z's would cancel and you have x. This one right here, let's talk about this. If you have f plus 2g and you see that same little bundle on the bottom, f plus 2g, you're like, okay, that's same on top and the bottom. I know that there is addition, but see how the addition is like in the package, inside the parentheses? The f plus 2g is still multiplied times f minus g. So this is an example where with multiplication we can cancel, and this would simplify to f minus g, right? When we cannot is over here, same situation. If there's a subtraction sign between the bundles, then you cannot cancel the f plus 2g on the top and the bottom. You'd have to leave it like this. Okay? Cool? Alright, so let's look at a couple examples. Today we're basically going to be saying, yay, I think something's equivalent, or no, I think it's not equivalent, I think they did something that they are not allowed to do. So we're going to look at two quick ones together, one that I think is going to be pretty quick and easy, one maybe a little more complicated. Then y'all are going to spend the rest of the time just practicing like 6 of these at your table. We'll check them before we leave. So first up, this one should be a quick rule that you've done a lot in algebra that you should be able to see whether you can do this or not. If I have 2 on the outside of x plus y, can I say that that's the same as 2x plus 2y? What property? Anyone raise your hand if you remember what property we call that? There we go. They distributed. They did use the distributive property. This 2, we'd have to multiply times both of these, right? Okay, so check that one off. That one's good to go. If it's true, you're just going to check it off and say good, true. If it's false, we're going to fix it, okay? That one's nice and simple. Next one. I've got these 2 fractions, 1 over 1 minus x plus 1 over 1 plus x, and I want to see if it gives us that thing on the other side. I would say this one, just by glancing, is a little bit harder to just do in our head and see if those are equivalent. So let's jump into this one a little bit more. I'm going to write it a little bit bigger up here so that y'all can follow along because it's squunched up down there. Okay, let's talk about adding fractions. Anyone, just before I jump in, just curious kind of like how comfortable y'all are with this. Anyone have an idea of what they would do next with something like this? Okay, that's good. So like I see a lot of people that are like not sure. Any ideas? Yep. No? Okay, so that's good. That's why I figured this one might be the harder one to kind of like talk about. So I'm going to relate this just to normal adding fractions because when we throw in variables, like it doesn't change the rules of math. Like same things apply as when we do a half plus a third. It just looks a little different because of the x's and stuff. So I'm going to talk through like what our steps would be here. So let's go over here. If I were to add these 2, what do I need to do? Giselle? I need to find a common denominator. So I cannot over here just be like, oh, 1 plus 1 is 2, and let me just add the bottom and I'm good. Because here, can I say 2/5? No. So I've got to find a common denominator just like I would over here. So let's think about how we find a common denominator now. What would y'all use as a common denominator for a half and a third? A 6. So what we could do is we can always multiply our this times 3 and this times 2, right? Like I can multiply them times each other, and that can give me my common denominator. So it looks a little more complicated with this one, but what I'm going to do is I'm going to multiply this one times this, and this one times this, so that I can get a common denominator of 1 minus x, 1 plus x. That's going to become my new denominator. I can go ahead and now start joining me writing this down underneath this part. I'm going to get a common denominator. Think of it like my 6, where I did 2 times 3. I'm just multiplying both bottoms together so that I have the same thing on the bottom of both of them. Cool? Okay. Now, when I change the bottom of a fraction, we're not done yet because I can't just be like, oh, and I'll just put my 1 on top of both of those, right? I can't change this to 6 and say 1/2 is equal to 1/6, right? 1/2 is equal to how many 6? 3 6. So not only did I multiply times 3 on the bottom, but I actually multiplied times 3 on the top too to make this into 3 6, right? With me? So over here, since I multiplied 1 over x times this part, right? I also need to multiply that on the top. I can't just multiply on the bottom, I gotta multiply that on the top and the bottom. So I'll have 1 times 1 plus x. I should have a 1 plus x on the top and the bottom in order to make that fraction equivalent to what it was before. Cool? So that's 3 6, that's this part, okay? For the 1/3, sorry, same thing, that's not just 1 6, that would be how many 6? So I just multiplied times 2 on the bottom, so I had to multiply times 2 on the top, right? So over here, I multiplied times the 1 minus x, right? See how this changed? And I added on the 1 minus x, which means I need to multiply times what on the top? 1 minus x. And so 1 times 1 minus x is 1 minus x. Cool? looks crazy complicated, but we're doing the same thing you would do like very quickly with numbers like that. Okay? Now, let's think about what we would do next. When you have 3, 6, and 2, 6, you just now say you have a total of how many? 5, 6. So we did not add 6 plus 6 is 12 on the bottom, right? We just keep the bottom the same. So now our bottom is 1 minus x, 1 plus x. That's like our 6, right? And then the top, we did 3 plus 2 is 5. But here we're going to say 1 plus x plus 1 minus x. We're just going to add all the stuff that's on the top. It just looks complicated. See how I just added straight across the top? Yeah? Okay. And the plus x and the minus x are going to cancel, right? And what's 1 plus 1? 1 plus 1 is 2. Okay. 2 on top. 2 on top. And on the bottom, you could leave it like that in factored form, but I noticed that theirs is actually, they used a difference of squares to put it together, right? Do first. Didn't this look like our do first? And in the do first, we said, let's not draw our box anymore. Let's just start doing it in our head. So 1 squared is 1. X squared is x, or sorry, x squared, yeah, is x squared. And then it's a minus, like that. So this is what this would equal. Therefore, is this true or false? False. They had the wrong thing on top. They did the bottom correctly, but they didn't do the top correctly. Okay? Alright. So, try to use that example. Try to use 1/2 and 1/3 or like any normal fractions to kind of think through how you find a common denominator when you see fractions you're adding together. You have 6 of these. You see 4 right here, and then there's 2 more at the top of the next page. I want you to try those before we get out of here at 12:05, so 8 minutes to try those, and we'll probably check them in our last minute, so more like 7 minutes, okay? Good. Talk to each other, see if it's true or false. Do like 1, and then go. So this first one's for like 30 seconds. Ryan, what do you think about the first one? True or false? Why? What's wrong with it? So if it's false, fix it. What would you do? Or what, if it's false, then you fix it?
Which one?
Yep. So basically what they did, this is the opposite of the distributive combination, we call calculation algebra. So if these both have an A, then I can pull an A out front, and I would say what's left in this term is an X, plus what's left in this term is Y, and this is okay, what is the same thing?
Hey, shooter and booty, and offset.
So there's no, yeah, no X's in this one, right?
Number 12?
So let's think about first what would be on top. So like here, like for example, we first found out, look over here, that because this was 1 minus x and 1 plus x, we had to multiply those together to get our new bottom. Right? So look at your bottoms. We have A and B, so what's our new bottom?
You were winning over
Okay, so notice what we're doing
I'm gonna
right here.
refund
The
your
ones
money.
are already there, so that's why we have ones.
Johnny,
All
put
we
my
did with
jersey on.
this is we took this and we multiplied it times 1. Just like here, we had 2 and 3, so we multiplied 2 times 3 and we got 6.
I'm playing this part.
So we're going to do with A and B.
You've been missing each other.
Yeah, I missed that shot, you know.
A, B, A times B.
Hey, not making it
Okay,
today.
so the new bottom
Eli.
of this fraction is going to be AB, and the new bottom of this fraction is
You know
going
Eli,
to be
you know,
AB. We just multiply
should I
them
say
together. Right?
Should I
Okay. When I change the bottom though, I can't just keep the top the same magically. The top's got to change too. So we have to figure out what we multiplied by. What did I multiply A by? So I have to, for this part, I have to multiply times B on the top as well. And what's 1 times B?
Oh, cause why not?
1 times anything is anything. 1 times 5 is 5, 1 times 10, 1 times
Hey, my fingers still
Okay,
hurt though.
let's look at this one. If I had B and now I have AB, what did I multiply by? I've got A.
Yeah.
See how this one's the same as this? This one's the same as this? Okay.
Don't worry, I found some.
Now it's time to actually add them together. So what do I have on the bottom? Stay the same, right? Just like when I had 6 and 6 second portions. And then on the top, I would have 3 plus 2, which equals 5, but it's 3 plus 2. Here I have what plus what?
B plus 6.
2 plus 8, because we're adding the top, right? There you go. That's it. That's it. What they did is they just added 1 plus 1 is 2, A plus B is A plus B. You can't just add it. They're wrong. They wrong. You try, but you wrong. You need to talk about this?
Huh?
So, let's reverse.
Oh, chill out, Brian.
Remember we said 2 times 3 gave us our 6 on the bottom? So if I've got A and E down here and I need a common denominator, I'm just going to multiply them together and say A times B.
I need to go figure this stuff
Okay,
out.
then I gotta figure out, I can't just change the bottom, I gotta change the bottom and the top. So for this one, I multiply times B, right? So if I multiply times B here, I need to multiply times B on the top, so I'm gonna get a B on the top, because 1 times B is just B. Okay, notice these, like if you re-cancel these B's, I'm back to this, right? So I didn't change anything, okay? Over here, I multiply times what? A, so I need to multiply times A on the top. And notice again, if I cancel my A's, I'm back to a 1 over B, so it's the same thing. Now I actually add it together. So when I said 3, 6 plus 2, 6 is 5, 6, the bottom stayed the same. So I've got some sort of total number of ABs. How many ABs do I have? I have B over here and A over here, so now I have B plus A is the amount that I would have. So that's what I have. Just like here, I have 2 plus 3, so I have 5. I just can't actually add them together because they're letters. Yep. Cool. So that one, they're wrong. Cool. How are we doing with our common denominators? Okay. Cool. So one of these ones, I don't think there's any that, yeah. So there's, just try these 6. These ones you will have to do the common denominator yourself because it's the last one. How are we doing? Yeah, so here, unfortunately, you can't just add tops and add bottoms. Because if you had a half plus a third, you can't just say that's 2/5. Right? That doesn't work. You have to change them to the same denominator and say like, okay, so just like you change these to 6, and you multiply 2 and 3, here we're going to multiply A and B. That's going to be our new for your top. If this used to be A and now it's AB, we add it on that part, right? I can't just change the bottom. If I change the bottom, I also, if I multiply times B here, I need to multiply times B. And here, if I multiply times A, here, I need to and then, just like I would add 6 plus 6, give me more 6. If I have ABs plus more ABs, and that's the number of ABs. How many total ABs do I have? B plus A. Okay. Alright, y'all. We're going to check them and get you out of here. So what's up? Do not pack up. Do not pack up. You should be checking your answers. So as I look around, I should see papers out, ready to go. You nearly packed up. It's close call. Okay, here we go. First one. True. Just distributive property in reverse. It's called factoring out a common factor. Next up, tells the difference of squares just with a fraction, so things got crazy. So that's also true. Nice. Next up, false Z, because they needed a Z in that last term. Okay. This next AB guy got crazy because that was another common denominator one. They tried to just add the tops and bottoms, so they were wrong. Should have been this right here, okay? If you happen to flip to the back because you're awesome, it was true and false, because this one you can't cancel the A's, okay? It doesn't, yeah, it doesn't, you can't simplify that. Yep. Bye, have a good rest of Wednesday. Which one? Same thing, just positive and negative, right? Square the first one. Square the last one. What's the
Hey, no, hold on. Wait.
Oh my God.